for binary classifications that we use. Again, in the ResNet, in our project, we use ResNet 50. There are a lot of ResNet variations available, but we use 50. The ResNet consists of 50 computation layers, and also the ResNet consists of the principles of speed sequential functions, and also it also works on the feature localizations concept. Here is our ResNet remote structures, and we also have pattern layer, dense layer, normal, and dense layer. And you can see that the parameters handled by the VGNet is something moderate amount. ResNet, the parameters here handling is very high. So now comes to the deep learning part. We need to preprocess the data, which is again is subgroup of machine learning. That's why it is a subgroup of machine learning, the deep learning. We need to process the data. Here we are using the image processing. But the first problem I already informed you that the thermal image is an infrared enabled thermal images. They are of very low resolutions. Another issues will be thermal image samples are full of noises. So the resolutions we are trying to figure it out what is the correct resolutions of that. So we find out Kalman filters can be a very good help in this case to just denoising the noisy images. Also can handle the low resolutions with limited amount of loss. So the Kalman filters, how it works? It works in the 5 different steps. One is initializations, state, estimate, predictions, update, and repeat. Like here, you can see that. Can I? Yeah. So the image initializations is like raw image set comes with the Kalman filters. After that, it has a state estimate. Then it can predict it. Then it can update estimates. Again, if there's a new image set coming in, it will repeat the same thing process again and again to update estimates. So now, once we implemented Kalman filters to our 2 different data sets, one is terms, another one is Charlotte-based Kalman data sets. Again, I wanted to tell you, Charlotte-based image data set is of very low resolutions, and also there are only 10 samples, 10 subjects that has been taken the thermal images for. But the point is, those people's image are very identical to each other. So they are trying to make it very much straightforward data sets, no variations involved. So you can see from these left hand sides, those are from Charlotte data sets, and you can see the differences like from Charlotte and these terms. You can recognize those persons second to very quickly, but the Charlotte data sets mostly they have this kind of people's images, and it's very hard to recognize. But still, we did it, but the Kalman filters, after the denoisings, you can see the denoise outputs. Maybe from the naked eye, it's not possible to distinguish too much, but you can see the blackness part is a little bit lower than the results we got it from our experiment from VGNet 90 and ResNet 50. We can see the differences of the percentage of accuracies. The third level here, VGNet 90, we have 94.26% accuracies, is the accuracy with VGNet. And also for ResNet, we have 95% accuracies with the same thermal based data set. Still, at this moment, at this present or current research domain, 94% accuracy is 95% accuracy is not accepted because we are planning to go for 100% accuracy. But who cares? Because the Charlotte thermal phase data sets are of very noisy and very much straightforward with similarity of their different subjects. That's what our CNN was not able to provide that much of high classifications. But once we feed the information to the top phase data sets, we know that the correct one. we got 98.03% test accuracies. Also, on the terms in the resident we got 90% for this training. Don't care about training because it is just like once you train more and more, it will get training. This is very again, those results are coming after this Kalman filter implementation. We tried before Kalman filter implementations and the accuracy was less. And also it was timely. The Kalman filter helps us here classify very accurately and it improves the performance of the CNS. Those are the results from our experiment. The top part is from solid compound phase datasets, which we have loss versus accuracy curve, and also we have loss versus accuracy curve for both different CNNs. One is VE19 and another one is response. You can see from the VE19 everything for our accuracy curves. It is in the range from 86 to 98%. So it is not from 0 to 98, it is 86 to 98. Are you able to see that properly? Last page, are you able to see that properly? I can zoom in. Let me see if I have some questions. Am I able to? Better, thank you. Yes, yeah. So here, from the solid thermal phase data sets, after implementing VG90, you can see that our accuracy curves is fluctuating, but not too much. After 4 to 5 epochs, it is getting the stable rate, and the validation is also marching to our precisions with the VG90. Now, with the same thing, solid phase data sets, we are implemented ResNet 50. Now the accuracy is jump up little bit from 86 to the lower range is now 90 to 99% or 96%. So ResNet is again has bigger amount of convolution neural nets. It has 50 convolution neural nets. So that's what the classification is taking the higher level compared to the VGNet 90. But once you go back to our thermal data sets, you can see that everything is getting very stable because subjects are of different, their facial expression and their facial images was completely different from one to another. So the point is the classifications will become so prominent with the vision rate itself. Now with the ResNet, now you can see the accuracy curve is from 90 to the range from 90 to 98% accuracies, and it's between the range of 90 to 90. Still acceptable at this moment because we are dealing with, not forget, thermal phase image, which has a lot of noise and a lot of low resolution image set. So, in summary, we presented a practical deep learning approach for thermal image classifications, and we are addressing the challenge posed by the complexity of thermal image markets and the availability of annotated datasets. The proposed approach to utilize the pre-trained CNNs, specifically resident 50 and CNet 90 to extract feature from thermal images, and then employ transfer learning to fine-tune the models with smaller annotated datasets. Also, the experimental results demonstrated the proposed approach's effectiveness in terms of accuracy and efficiency, and utilizing the Kalman filters effectively reduce the noise and also can handle the low resolutions. Again, we achieved a remarkable normalized training and test accuracies using VG8 and 19 and less than 50. But we can notice that curved thermal phase datasets always perform well because of their variations of their datasets and their clarity in the datasets. Our future plan that we can implement our applications in security, medical, and industry domains where actually thermal image has been used. Our future research can also explore extending the approach to more diverse data sets and real world scenarios there is applicable we can apply it. And we are potentially opening the door to an even broader applications of thermal imaging techniques because we know that these thermal image sensors are very stagnant and also kind of monopoly is going on of thermal image sensing techniques. So we can, if we potentially explore our research area, then thermal image sensing tools and applications will be again can be created by diverse people. So that can have a more potentials to improve our image capturing techniques. Again, I am Dr. Chatterjee. So we received several grants from different organizations. Recently, we received 800,000 grants for deep technologies, and also almost in the year of 2023, we achieved almost 1 million grants. From 2017, 2020, 2019, we achieved almost 2.6 million grants for deep learning techniques and implementations and research, and also for the university's progress. And thank you, everyone. And if you have any questions, please, and if you have any suggestions on this research, please suggest us. And we are practically open for any high-end collaborations in deep learning research, and I all appreciate not only my research is also been for the Zoom call. So he is in the Zoom call in the lab.
Yes. Hello.
So we appreciate all your time. And this is a